Hello everyone, welcome back to the channel. Today we are tackling a classic medium level problem on Leetcode, problem number 271, Encode and Decode strings. This is a premium problem on Leetcode, so I am sharing the problem statement from Leetcode. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. The problem is a design problem where our task is to write two functions, encode and decode. In the encode function, we are given a list of strings. Like in example 1, we have the strings like lint, code, love and you. And our task is to convert it to a single encoded string. Think of it like packing your lunch into one box. This single string is then sent over the network. So one way to encode the string is like this one shown here. Or we can have a string around some other character like hash and produce a string like this one. And then on the other side, the decode function takes a single packed string and unpacks it into original list of strings. So here, for example, if we encoded this list of strings, decoding it should give us back the original list perfectly preserved. The challenge here is to handle edge cases. What if a string is empty? Or what if a string itself contains a special character that we are using for encoding? Our design needs to be robust enough to handle all of that. Alright, let's start with the most straightforward idea that comes to mind, what we call the naive approach. A simple way to encode a list of strings, say these ones, would be to join them with a special character or a delimiter. So for example, let's pick a character that we think is unlikely to be in the strings, like a hash. So the strings hello and world would be encoded into the single string hello hash world. And to decode it, we can just split the string by hash, and this seems to work perfectly for this example. But what if one of our string itself contains a delimiter? For example, if the input is like this, where string hello itself contains a hash. Now, if we encode the list using the naive approach, we will get a string like this one with two hashes. And if we try to decode this string by splitting it at hashes, we will get back these three strings instead of two strings in the original list. So our simple delimiter based strategy has failed because it can't distinguish between a delimiter we added and one that was part of the original data. So that's the classic problem with the delimiters, and the root of issue is ambiguity. And to solve this, what if we could have the length of each string ahead of time? For example, if we knew that the first string has 6 characters and the second string has 5 characters, then we could have just read exactly that many characters in the encoded string and get the original string back. And one way to achieve this is by storing the lengths in a separate array. But we can't do this because the problem states that we can only send a single string over the network, which means we cannot send a separate array for the lengths. So the key insight is to embed the length of the string inside the encoded string itself. And this brings us to the optimal approach of length prefixing. So for every string in our list, we can create a header that contains its length followed by a delimiter, and then we can append the string itself. So for example, the length of this string is 6. So we encode the first string as 6 hash hello with hash. Similarly, the string world has length 5, which we can encode to 5 hash world. And now, since we have the length information, we can easily concatenate these strings and get the string like this one. And you would have already figured out how to decode it. We can scan the string from beginning to find first hash, and this gives us a number which tells us the length of the first string, which is 6 here. So from here on, we read first 6 characters and decode the first string hello with hash and add it to our result list. And we repeat this process, find the next hash, get the length 5 here and decode the string of length 5 and add it to the result. And now, since we are done with all the encoded characters in the string, we have successfully decoded the string back to the original list containing strings hello with hash and world. So this way, we don't care about if there is a hash or the delimiter inside the string itself. Now the time complexity of this approach is O of n, where n is total number of characters in all the strings, because we iterate through each string once to calculate its length and build the encoded string. And for decoding, we also process each character once. Hence the time complexity will be O of n, and the space complexity will be O of n as well for storing the encoded string. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on the left and Python on right. First, let's look at the encode method. Our goal is to turn a list of strings into a single string. In Java, we initialize a string builder, and in Python, we use a list. Both are efficient ways to build up a new string piece by piece. We then loop through the input list, and for each string, we first get its length, which we append to our builder, and then we append the special delimiter, which is hash here, and after that, we append the actual string. And once the loop finishes, the string builder or the list contain all pieces of our encoded string. We just need to convert it to a final string, which we can do by using toString in Java or join method in Python. Now let's look at the decode method, where we unpack the encoded string. For that, we create an empty list, which will hold our decoded strings. Let's also initialize the pointer I, initially equal to 0, to keep track of the current position in the encoded string. Now we will loop through each character in the string using the pointer I, and inside the loop we need to find the length of the next string. For that, we can use pointer j, which starts at the index I and continues until it finds a hash character. And notice that we are using a while loop here to find the length of the string. That's because length itself could be multiple digits like 10, 70 or even 100. A while loop here ensures we read all the digits of the length, not just the first one. At this point, we know that characters between I and j represent the length of the string which we want to decode. So we parse this substring into an integer called length. And now that we have the length, we can extract the original string. It starts right after the hash character, which is at j+1 and has number of characters equal to length. So we grab this substring and add it to our result list. And finally, we update our main pointer I to the beginning of next encoded block, which is at j+1 plus length. And this loop continues until all parts of the strings are decoded, and in the end, we return this result list. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.